Good idea to have some more piecewise fun. Let's take another example from this page. We can take a hard one if you like. Isn't that what you're supposed to do? Show the hardest thing? So here's h, okay? M of x, who cares, we'll call it y, equals negative 3 over 2, the absolute value of that stuff, plus 4. Well, I'll write that down here. I'm not going to write down m of x, I'm just going to write down y equals negative 3 over 2 times the absolute value of negative 6x plus 4. Well, right now I can see that the x-intercept is going to equal 0. And I know that because negative c over b is negative 0 over negative 6, so it equals 0. So the x value of the vertex, because it's not plussing or minusing anything, negative c over b equals 0 over 6 equals 0. So the vertex is here, 0, comma, plus 4, 4. So that's the vertex, and I know that it opens downward because it's a negative sign here. So when I graph it, and I'm only graphing it so that I can, so it can help me understand, to help me understand what it's going to look like. It's going to look something like this. I don't know exactly, but it's going to look something like this, I'm pretty sure. Yeah, the vertex is 0, 4, so that would be 4. And in order to describe this stepwise function, I'm going to have a function that describes this when we're less than 0 and a function that describes it when we're 0 or more. So I can start writing down my two answer components here. And one's going to be when x is greater than or equal to 0, and the other one is when x is less than 0. Okay. Key is, what's the function that describes that side of the line? What's the function that describes this side of the line? Well, let's create the two equations here. One of them is simply writing it out as if there's no absolute values going on. Y equals negative 3 over 2 times 6x, negative 6x plus 4. So negative 3 over 2 times 6x equals 9x plus 4. So y equals 9x plus 4. That's really quite simple. Y equals 9x plus 4. Well, what side is that on? That must be this one because it's positive slope. So this must be when x is less than 0. When x is less than 0, y equals 9x plus 4. So this one, let's color code this as well. This one is this part of the line. And it's not just a positive slope that gives me that. Yeah, it is the positive slope that gives it away. You'll always be able to recognize the slope if it's a linear function. So the other one is going to multiply this junk in here by minus 1. So it doesn't matter if it's minus 6x or 6x, it will be the same value. So y equals negative 3 over 2 times 6x plus 4. So y equals negative 9x plus 4. No big surprise. Y equals negative 9x plus 4. Remember, these lines are pretty much always going to be symmetric, and they're always going to reflect over some vertical line. X equals something or other, whatever the vertex is. So we know that the vertex is 0, and so we found it pretty easy to graph that. So there we go. That's what goes there, and that's what goes there. So the answer that they'd be looking for in the book are these here. This is the function that describes it where x is greater than or equal to 0. This is the function that describes it when x is less than 0. This function also describes it, I think, when x equals 0. Yeah, actually they both do. I'll have to look that up.